up to this point, I've created a regular file, encrypted file, that contains both an outer partition and a secret partition. Plus, I use some steganography techniques to take that encrypted file and append it to a video. In both cases, all of the secrets that these files contain, the file and the copy of the file contain, are all encrypted, and everything should be good if nothing has accidentally leaked out to someplace. Now, actually, in doing this demonstration, I intentionally made some mistakes, just so that in this section I can actually show the mistakes that were made intentionally, and we can discuss some of the edge cases here and why they occurred. So to actually find all of these secrets, and who knows, maybe there are other places also, but we're going to actually do a fairly extensive search for any of this secret stuff. We already earlier in the setup talked about this strings match script, which takes an extended regular expression in the name of a file and will actually run strings on it and will spit out some information, the file name and anything that matches the regular expression. If there are no matches, then it just puts out nothing, no file name, nothing matches. So ideally, we'll just get a bunch of no output. But when things do leak and it discovers them, we'll get the name of the file plus the contents of what actually did leak. Okay. We need to run that on actually every file, at least every regular file on the entire system. Now, to do that, and it's going to take a while, I use time to actually find out. That's a program that'll tell me how long this all took. Last time I did this, it took slightly less than 6 hours, and I made some changes to the script, and I'm actually suspecting it's going to take a lot longer than that. So this find here from SIG drive, this is actually kind of like the root of everything, and all of the mountable drives, all the drives that are mounted will show up as different letters here. So there'll be SIG drive /C for the root of the C drive, okay? And if I had a VeraCrypt volumes mounted at like an F or H drive, then I get a SIG drive F or a SIG drive H here, okay? Dash type F is telling me that the regular files I'm only interested in. And unfortunately, some of these files might have spaces in their file name, so it's just something I need to know to do. This dash print 0 dash null, that combination of the two things kind of allows spaces in file names. All of those file names get piped into this program called Xarg, which is actually going to run whatever program I specified here, that strings match script, on each one of the inputs. So it'd normally be each of the lines, but it's because of the print 0, it's everything that's separated by a null. It's going to run it, and the dash N1 says one at a time. It usually, without that, it just puts as many of them as it can, but strings match can only handle one at a time. That's one of the reasons it takes a long time to run this. And here's the regular, it's an extended regular expression that we want to find. So we want to find anything that has the word secret in it, and then 4 equals for the end there. This question says 0 or 1 times. So 0 would be of whatever's in front of it, and that's the not A. So if it's 0 times, then it'd be 4 equals, secret, and 4 equal signs. If it got it 1 time, then it'd be 4 equals, not A, secret, and then 4 equals. So it'll find both of those and send them on out. Okay. And this is going to take a long time to execute. So let's jump on over to the VM. In some ways, just to cause some difficulties, VeraCrypt right now has nothing mounted. So the encrypted volume with the secrets in it is not mounted, so it should not show up anyplace. But I am going to leave the VeraCrypt program up here, and hopefully, and I'm fairly sure this is true, it hasn't tucked those passwords away in any temporary file or something around. Okay, if it did, then it's going to be discovered very quickly here. Okay. So I need to run this perform find secrets, and I do that from a SIGWIN terminal, but I can't use this terminal because if I look at the ID here, well, that's interesting. There it goes. I'm not sure why it wasn't taking that immediately. There we go. It is this IE user, which was the default user account for this evaluation version of Windows. The groups here, there are various groups here. The main one is it does not have the administrator group, so there's a bunch of files it can't get to. So I want to get out of this terminal, which is not that useful to me. I'm going to right-click on SIGWin terminal, and I'm going to say run as administrator. Okay. And there he is. And this time when I do ID, you're going to see here, where to go? The group, account and member of administrators group. Okay, and there's administrators. So this terminal now has a lot of permissions. It can basically look at all of the files now on this system. Okay. So at this point here, what I need to do is I mostly just need to run that script that I talked about and then be very patient. I need to take all of its error output and send it to normal output. This is just some shell syntax. And I'm going to send all of that output into a file. This team will actually send it to the screen and send it to whatever file I specify. So I'm going to say the file. Okay. And press enter. And so far, because I've got no output there, it hasn't found any problems. But this is going to need to run a long time. This is running. I'm going to now jump into going to let it run, and you're going to see a fast forward, and that fast forward is going to be a significant number of hours. Although it took 624 minutes or 10.4 hours, we're back with the Perform Find Secrets completed here. The reason it took a long time is a lot longer than the 6 hours it previously took is that previously I had used a -P4 option with Xargs, which said I could run each of the Xargs items up to 4 times in parallel. But there was some MP locking issues where the results didn't come out consistently. So I needed to get rid of that and run all of this serially. So it actually did take quite a while, more than 10 hours for this to complete. But it has completed, and we do have some output. So it actually did discover the secret eye catchers in various locations. We can actually find out how much it actually found, how many files it found it in, through the output of this following command. Remember that each of the eye catchers, each item found, it starts with at the start of a line, that's that caret symbol for regular expressions. We'll get a line with 4 dashes, space in it in the output file. Okay, and if I take that and I just count how many lines of output do I get, I've got 11 lines. So basically, there were 11 regular files that were discovered with the secret or the not a secret eye catcher. And we can actually get the actual file names right here. So for example, there's a file, sig drive c sig164 home IE user bash history. This is actually a file by default that the bash shell creates and maintains command line history in it. Fortunately, this file, if we look at its permissions here, we see this RW dash, then dash, 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 dash. The first RW dash means that the user, i.e. user, can read and write the file. But the next set of 3 dashes and 3 dashes, those would be for other people in the group. The group is none. And other people, they don't have any read, write, or execute permission. So besides IE user and processes that can kind of override these rules, like the administrator, they can't look at the contents of that. We can easily, though, go in, because I'm running as IE user, I can easily go in here, look at this file, and see it. We can also see within the output file, it not only displayed that file name, right up on the top here, bash history, it also listed out the contents that it found here. And the reason we have some secrets in here, such as secret, what is it, 3223, redirect out to that file, is because this user in creating this was actually intentionally done, has made a major flaw here. The major user error that was caused here is the user here has actually typed secrets as command line parameters to commands being executed, and then those are being captured into bash history. So we see the secret name of a directory. We see the secret contents of a file being directed out to a file name that's also a secret. Okay. And then we got VI of a file and make dir this file echo. Okay. We can also see here this next place it found it in out find secrets. This is actually nothing to be concerned with here. This is simply a recursion of the perform find secrets things, because every time perform find secrets found anything, it wrote its output to this file, and then later it found that actual output file and it performed the same thing, so it's really displaying just the same thing. Finally, we come down here, next one here we see we've got various things under users, i.e. users app data, and these are somewhat of a concern, but also somewhat not of a concern. What these are is you will find cases where things like the file name has been leaked. It's in there. And actually, if I come back and I look at the file permissions on these files, at least by default here, any user can actually read these files. Okay, so this file here, as an example, let's just grab that. That has read, write, execute for the owner, read, write, execute for the group, and then really of a concern, read, nothing, execute, but the read for others. So although there might be some directories, and I've checked and this is not the case, but some of the directories leading to this might block access by other users, at least the actual file is allowed to be read by others. So others can look at this file, look at the contents on it, and see it there. Okay. And then that does have some things that we normally would keep secret, things like the directory names and the file names that are actually within the secret partition. Fortunately, if we look for some of the contents, the secret contents of the file, I've not discovered any cases where these app data files have actually leaked file contents, but the names of the files and directories are definitely being leaked. Okay. At a high level, it took 10.4 hours to do this search. Previously, it only took about 6 hours, but that dealt with this -P4 option that I can't use anymore, at least for now. It'll take some coding, additional coding to get around some race conditions to have the results come out. These are the 11 files that it actually found them on. There were no detected cases of leaked passwords. That's good. Okay. Secrets leaked to bash history. Those were basically because secrets were typed in on command line arguments. This is usually considered a user error, but good to demonstrate here. Okay. And then the secrets shown in outfind secrets, that's a recursion thing of, it's just a holdover from the actual process of finding and recording the secrets that were found. All of the remaining leaks were found in various users, i.e. user app data files. Okay. There was no discovered leaks of any file contents. There was, though, significant leakage of directory and file names, which may be considered an issue or maybe not. But you could actually discover quite a bit by just looking at a user's various app data files as to what applications and which files and directories they've been in.